Hey guys, welcome back to my channel where we explore interesting math problems. Today's video is part 1 of 2 videos where I will walk you through a contest from the 2022 to 2023 ASMA Senior Division, which is typically for high schoolers. So for those of you that don't know, ASMA stands for American Scholastic Mathematics Association, and each year it has 6 contests. The one we're doing today is contest number 4. Each contest will have 35 minutes for 7 questions that can range anything from geometry to algebra to counting problem, and calculators are allowed on this contest. In this video, we will only go through questions 1 to 4. And although we have on average 5 minutes per question, let's see if we can do them with both speed and accuracy. So question 1 reads, the supplement of angle A and the complement of angle A are supplementary. Find the degree measure of angle A. First, let's translate this first sentence into an equation that we can work with. And to do that, we need to turn angle A into a symbol. So we let angle A be theta. Now let's break down this equation. Supplement and supplementary means two angles add up to 180 degrees, while complement means that they add up to 90 degrees. So overall, we know that this and this are supplementary, so two things are going to add up to 180 degrees. So we have this. The first part is the supplement of angle A. So whatever can be added to angle A to make 180 would be the supplement of angle A. So it must be 180 degrees minus angle A or theta, because adding that to angle A or theta would just give you 180 degrees, which is the definition of supplement. The next part is the complement of angle A. Same thing here, except the angle added to A makes a 90 degrees. So it's 90 degrees minus angle A or theta. So now we just need to solve this equation. Simplifying and dividing, we get that theta is 45 degrees. And since the question is asking for angle A and theta is angle A, 45 degrees is the answer to our first question. On to question 2. The question says, in writing the integers from 0 to 999, how many integers will contain the digit 3 at least once? So we need to somehow find all integers from 0 to 999 with at least one digit containing 3. Although there are several ways to do it, such as adding up caseworks of when 3 appears in only one digit, in 2 different digits, or in all 3 digits, the fastest way to do it is to find the total number of integers from 0 to 999 and then subtract the integers that don't have any 3 in them, since doing so would mean whatever remains must have 3 in there somewhere. To find the total number of integers without any 3 in them, we can think about the fact that all integers in a given range would have 3 digits if we think of single digits like 1 as 001, or double digits like 22 as 022. So how many ways can we fill the first digit without using 3? 9 ways, since there are 10 different numbers from 0 to 9, but we subtract 1 because we don't want 3. So we have 9 different integers that we can choose from here. What about for the second digit? Same deal, still 9. And for the third digit, it is still 9 possible ways to fill it. And since how we choose a number for each digit is independent of the others, we multiply these possibilities together, giving us a total of 729 numbers from 0 to 999 without the number 3 appearing in their digits. Now we can go back to our big equation and start to plug things in. The total numbers of integers from 0 to 999 is 1000 minus the number of integers without 3, which is 729 from what we just found. This equals 271. So from 0 to 999, there are 271 digits that contain the digit 3 at least once. Third question. S is the set of 7 consecutive integers whose sum is 7. T is the set of 8 consecutive integers whose sum is -12. How many elements do S and T have in common? Let's first write down the set of elements within S. Since we know that there are 7 consecutive integers, we can let the first integer be represented by A, and each succeeding integer with 1 added to the previous one. Like this: a plus 1, a plus 2, and so on, which makes 7 consecutive integers. And since we're given that these add up to a sum of 7, we can put it into an equation and simplify it and solve for a, which is equal to -2. Now, we can do the same thing for the elements in T. Since there are 8 integers that are also consecutive, let's have the first element be b. And we can then write out the 8 elements like this, similar to how we did it for S. Again, we know the sum of all these elements is -12. So we add them up and equate it to -12. Simplifying and solving for b, we get that it's -5. Now, because we know what a and b equals, we can substitute them back into S and T respectively, so we can know what the numerical values for each element are. Substituting S and substituting T. So the question asks for the number of elements S and T have in common. And from here, we can see that they both have -2, -1, 0, 1, and 2, which is a total of 5 elements. Lastly, question 4. If f of x equals x plus 3 and g of x equals x squared, find all the solutions of f of g of x equals g of f of x. So we are trying to find the solutions of this equation. To simplify this into something workable, first we substitute g of x with x squared in here and f of x with x plus 3 in here, which would look like this. Now, here's the part where we need to be careful. Over here, the function has input x. However, now we are inputting x squared instead. So if x squared is replacing x, then f of x squared would be x squared plus 3 instead of x plus 3. Similarly, for g of x plus 3, instead of just squaring the input of x, we would need to square the entire input, which is x plus 3. So now we just need to solve the question. Expanding, simplifying, then dividing, we get that x is equal to -1. And that is the only solution for our given equation. So that concludes question 1 through 4 of this ASMA contest. We managed it in under 10 minutes even though we have 20 minutes to do 4 questions. Give yourself a pat on the back and I'll see you in part 2.